We'll also need to review vectors if we want to be well equipped for the dangerous landscape that is physics. Vectors are probably the most crucial mathematical idea in all of the physics we're going to cover, so the rest of this module is devoted only to vectors, just so that you're ready for the rest that lies ahead. Well then, let's get on with it. What is a vector? I'll give you a crappy definition first, and then we'll try and expand upon it. The crappy definition is a vector is just an arrow. That's it. Just an arrow. But that isn't really a good definition to work with. At least, it's not really that helpful in a formal sense, so we should try to tackle the problem of what a vector is in a different sense. One useful question we might ask is what makes one vector unique from another vector? In other words, if we had a collection full of vectors, then what would make one vector unique from each of the other vectors inside of that collection? This turns out to be a bit of a difficult question to answer for now, so we're going to think about the inverse question, which is a lot easier to answer. What I mean by that is we can ask, what would ensure that two vectors are exactly identical? In other words, what are the criteria the two vectors have to satisfy in order to ensure that they are exactly the same vector? Well, one idea is that if you have two vectors and they have the same starting point and the same ending point, then they are indeed the same vector. You might be wondering, well, what about the thickness, or what about the color, or anything else? Do any of those matter? They're not important mathematical properties of a vector, so we'll just say for now that if they have the same starting point and the same ending point, then that's all they need to be the same vector. But I'm going to burst your bubble even more in saying that actually you can find more vectors which don't have the same starting point and the same ending point, but they are indeed the same vector as these vectors that we have here. So now what if we take these two vectors that are stacked on top of each other and we just move one of them a little bit? In fact, if we move one of the vectors, then it's still exactly the same as the vector we have over there. They are exactly the same vector, despite that they clearly don't have the same starting and ending point. Huh, that's interesting. So we see that our basic definition of what makes two vectors the same is not going to cut it. We're going to have to change this definition a bit, but first, let's sidestep that and talk about something else.